Venus. Undoubtedly the most hellish place in the solar system. If by some miracle you survive on its surface at 700 degrees Fahrenheit, you'll be soaked in burning sulfuric acid rain and then crushed by an atmosphere 92 times heavier than Earth's. It's like sinking a kilometer deep into the Pacific Ocean inside a giant slow cooker filled with acid. Volcanologist Robin Andrews even jokes that some deity had a really bad day and decided to turn Venus and its inhabitants into hell to serve as a warning to others. But seriously, what the hell happened to Venus? What secrets does the history of this terrifying planet hold? Was it ever habitable, and could it be in the future? Get comfortable, friends, because our segment, Planetary Stories, is back. We're waiting for your suggestions for future episodes, but for now, we're heading back 4.5 billion years to the good old days, before the internet and anime, when everything roamed around a gas dust disk, breathing fresh hydrogen. As mentioned in the Mars episode, the first to emerge was Jupiter, simply because gas is lighter and clumps together more easily. Following the same logic, Saturn formed next, then the icy Uranus and Neptune, whose structures are somewhere between gas giants and rocky planets. But then things got weird. Logically, since there was the most dust near the Sun, Mercury and Venus should have formed first. Yet, the opposite happened. The first rocky planet to take shape was Mars, compact, low in mass, and located near Jupiter, which cleared out space nearby. Then came Earth. Meanwhile, Venus and Mercury might actually be the youngest planets in our system. There's not much to say about Venus's size and internal structure. If you sliced Earth and Venus in half, shuffled the pieces, and gave them to geologists, at least half wouldn't be able to tell which is which. Venus is only a few percent smaller than Earth, and both have an iron core, a hot mantle, and a crust. Just like on Earth, Venus's crust is periodically ruptured by volcanoes. But here's the kicker. Venus has tectonic plates too. On Earth, these plates move over magma, forming continents that drift, merge, and split apart again over time. Most scientists now agree that Venus underwent similar processes not just in the past, but they are still happening today. All in all, it's Earth's evil twin. But how did it end up this way? Scientists don't have a definite answer, but they do have observations. The first clue? Venus has two major oddities. First, it rotates in the opposite direction of Earth. Second, it does so incredibly slowly, so much so that a day on Venus is longer than a year. Venus orbits the Sun in 224 days, but it takes 243 days to rotate around its own axis. This is the perfect place for introverts to watch the sunset. You'd have plenty of time to reflect on everything. Scientists link these two peculiarities to Venus's hellish climate. Most attribute its long days to the planet's proximity to the Sun. The star's gravity slows Venus down, and Mercury is proof of this. It's also a slow rotator. Case closed, albeit reluctantly. But the direction of Venus's rotation? Now that's a real mystery. Venus is the only planet that spins clockwise. Scientists have a few theories. The most popular one suggests that Venus collided with another celestial body in the early days of the solar system, similar to how Earth crashed into Theia, leading to the formation of the Moon, or how Uranus got so exhausted that it just lay down on its side. Calculations show that to reverse Venus's spin, it would have needed to collide with a planet similar in size. And in the chaotic early solar system, such planetary traffic accidents were plenty. This could also explain some of the climate nightmares Venus later experienced. But there are more exotic hypotheses. A paper in Scientific American proposed that Venus originally rotated normally, but at some point it simply flipped upside down while keeping its original spin. The culprit? Possibly the Sun itself. If Venus wasn't fully stabilized after formation and was slightly tilting over time, solar gravity could have gradually tipped it over, leaving it in its current bizarre state. But let's set that aside, because the biggest question that keeps scientists up at night is, was there ever life on Venus? With Mars, we're fairly confident that there was, or at least could have been. But Venus? That's still a complete mystery. We haven't studied Venus in as much detail, but indirect evidence suggests that in its early history, it might have been indistinguishable from Earth or Mars. Oceans, mountain ranges, volcanoes, and all that good stuff. Moreover, the Sun was weaker 4 billion years ago. And since Venus was the closest of the three rocky planets to the Sun, it would have been the warmest as well. So all the conditions for life could have been there, maybe even more so than on Earth or Mars. In 2023, a major study from Brown University was published in Nature Astronomy, analyzing the composition of Venus's atmosphere. Referring to the vast amounts of carbon dioxide and nitrogen in Venus's atmosphere, scientists have definitively concluded that such levels could only have accumulated if Venus once had plate tectonics similar to Earth's. No other simulations produce results matching what we see today. This means that, at some point, Venus's conditions were no worse than Earth's, possibly even better. How long did this last? We don't know for sure. There are theories suggesting that Venus might have been habitable as recently as 1 billion years ago. In 2019, NASA conducted 5 large-scale simulations of Venus's past. All 5 showed that for at least 3 billion years, Venus could have sustained liquid water, with surface temperatures ranging from 68 to 122 degrees Fahrenheit. The most pessimistic simulation suggested that life on Venus vanished 1.5 billion years ago. The most optimistic one, only 500 to 700 million years ago. Just think about it. By that time, Earth already had its first plants, and animals were about to emerge. And all those billions of years right next door, Venus had conditions just as good, if not better than Earth's, without glacial periods to mess things up. But then, disaster struck. Scientists call it the Great Resurfacing Event. In 1989, NASA launched the Magellan spacecraft, which thoroughly mapped Venus. It revealed that nearly the entire surface is geologically young, about 500 to 700 million years old. In other words, at some point, Venus's interior literally spilled out. The planet was flooded with magma, which slowly cooled and solidified, forming the Venus we see today. If future archaeologists ever dig deep enough, they might uncover evidence of past advanced life. No joke. But why did Venus erupt like that? That's still a mystery. Scientists lean toward plate tectonics as the culprit. On Earth, tectonic plates release heat, preventing the planet's interior from overheating. Venus had plate tectonics too, but at some point they stopped or nearly stopped moving. The planet's interior began to overheat, and anyone who's ever eaten spicy Indian food knows where that leads. These recent discoveries have been groundbreaking because, until now, scientists believed that plate tectonics were either present or absent, with no in-between. But Venus suggests that tectonic activity might be a cyclical process, one that could pause and then resume under certain conditions. So, the big question is, could Venus's plate tectonics ever come back to life? Because logically, if this is true, then planets could, in theory, become habitable again. As for Venus, is it habitable right now? That's still an open question. At an altitude of 40 to 50 kilometers, Venus actually offers Earth-like pressure and temperatures. Soviet Venera probes detected micron-sized particles in the clouds at these heights. Coincidentally, that's the typical size of bacteria on Earth. Unfortunately, the probes lacked the necessary equipment to confirm their nature. What they did detect were hydrogen sulfide, sulfur dioxide, and carbonyl sulfide, in proportions that, on Earth, would strongly indicate biological activity. But in planetary science, there's a simple rule. If you haven't physically touched it, it doesn't count as life. And even if Venus does harbor life, it wouldn't be of much use to us. Unlike Mars, which has water and some regions where humans could survive with minimal technology, Venus is a nightmare for colonization. Floating cities in its clouds? A cool idea, but ultimately a death trap. That's why colonizing Venus isn't considered a serious option. However, terraforming it? That's another story. And because Venus is so extreme, the proposed solutions for transforming it are some of the most ambitious in history. Some scientists have proposed nothing less than bombarding Venus with thermonuclear warheads. A nuclear winter on Earth would be catastrophic, but on Venus, any cooling is precious. The idea? Freeze the CO2, let it fall to the surface, and keep nuking Venus for generations until it's cool enough to even consider landing. Of course, once that happens, all that frozen CO2 would need to be dealt with before it sublimates back into the atmosphere. But that's a problem for future generations. Ours? Our job is nukes, nukes, and more nukes. In fact, we should have started yesterday. A more elegant and realistic solution was suggested by Carl Sagan. He pointed out that on Earth, Bacteria once consumed CO2 and oxygenated the atmosphere. Venus has way more CO2, but with enough microbes, we could trigger a similar event, lowering greenhouse effects and bringing temperatures down to survivable levels. And then there's NASA's most practical solution, sun shields. Some could be placed at the Lagrange point, while others could float directly in Venus's atmosphere. Given the planet's dense air, floating structures would be relatively easy to engineer. Specialists could even live in airships nearby, actively managing the process on site. Which, in the end, isn't much harder than digging beneath the surface on Mars and fearing to step outside to avoid lethal radiation. If you enjoyed our little cosmic deep dive, don't forget to hit like. That's all for now. See you next time, friends.